Hello. So you have, we have a special going on today on knowledge. It's a BOGO, buy one, get one free. We're going to do day 3 and day 4. Day 3 is long division. Day 4 is something called synthetic division. Today's also a special day because you get to surf the web on your phones today. So if you've got your phones out nearby, get it to your very favorite web browser and then set it off to the side, and I will give you the URL. I'll give you the URL about halfway through. Okay? All right. Let's do some long division. You remember this guy?
Yes.
Yeah. If I wanted to say it as a division problem, what would I say? 128 divided by 2. And if I wanted to write that, I would write 128. I would write the division symbol, which if you haven't noticed looks like a fraction. And then I would write 2. Right? No big deal. If I wanted to solve this division problem using long division, how would I write it? Okay, I'd write the 128 and then?
The little house.
The little house around the 128.
Wait, that's not the right one. That's square root.
So you want it written that way?
Yes.
Okay. All right.
Miss, is there a difference or not?
Yes. The one that has like this usually has another number.
Yes. Yeah, okay. So I love this question. Okay, I will get sidetracked on this. Okay, so I wrote this way because this is how my brain interprets the long division symbol, and the square root this way.
Oh.
So that way there's a ledge for that little number she was talking about, which is called the index. We'll do a 2. 2 and 2. Okay? So the first one is what some of you like to do this with, which is fine. So if you want to write it that way and that helps you, I'm completely okay with that. It will not bother me if you write it this way. But the square root, I try to put a little ledge because in my head, the way that I kept it making sense to me is that this was the house that I grew up in. And the house that I grew up in, underneath the front, above the front door, was a little balcony porch thing. And that's where I would climb out of my window to sit on to watch the fireworks display every 4th of July.
I should say sneak.
I know.
And I would see it. Look, guys, I was like 5 when I lived in this house, okay? And I still remember my mom freaking out. Quit climbing on the roof!
Mm-hmm.
Yeah, we finally compromised. And my older brothers and sisters who were like 14, 15, they would climb out of the window and sit on the roof. And I would sit in the windowsill. So that way, if I toppled, I would land into them and take them out with me. I was okay with this, yeah, right? I think my mother was okay with this too. But yeah, so I'll write my regular divisions like this, kind of curvy and round so that there's no place for anyone to sit, no place for the index. And then the radicals, square root thingies, I'll put the little porch so that there's a place for the index to sit.
Wait, so the one with the little curve is the same thing as the bottom?
As the bottom.
Oh.
Is that okay with you?
Yeah.
Okay, cool. Fabulous. So I'm going to work on this one. And then the 2 on the outside. Yes? All right. I love those conversations. Okay, now how do I do this division?
Wouldn't you just put in the calculator?
Wait,
If I
you
didn't
wanted
have a
the
calculator.
right way? You check which one goes into the 12 and then which one goes into the 8.
Okay.
So 6.
Yeah, so you okay, but why not the 1? Why did we skip the 1 completely?
No, the 12, the 2 can't go into the 1.
Right, 1 isn't enough for 2 to fit. So I scoot over a digit and go, okay, 12 is big enough for 2 to fit.
And that'll be 6, right?
And it goes in 6 times. If I had 12 students, I can make 2 groups of 12 students, and there's 6 students in each group.
64.
Beautiful. And so that's a 12, and I subtract by changing the sign.
Then you bring that
The
one
8
down.
falls. I do it again, and it's a 4, and 4 times 2 is 8, and there's no remainder. And everyone's happy. Yeah, easy, right? Let's do it with this next one.
That one looks kind of hard.
It does. But let's do the exact same process.
So
Okay.
193
193
divided by 4.
divided by 4.
Isn't it Why are you writing it there instead of?
On the second one?
Yeah.
Because
Does it
I
matter?
no,
Okay.
I had a scribble mess there, so. Okay. If I have one student and I want to put them in groups of 4,
You can't.
that would make a big mess, and I'm pretty sure that the principal would fire me if I try to put one student in a group of, like, into 4 groups, right? Yeah, let's not. Your group gets the arm, your group gets the foot, let's not. All right, 19 students now
That's not in
into 4 groups. It's not.
there. So it doesn't go.
Well, 4
It-
times 4, it's the closest
It's
one.
the closest one. So I can put 4 students, or I can put 19 students into 4 groups. How many students did I use up? 4 times 4 is 16. I used up 16 students, which means I have 3 students hanging out, not doing anything. So I'm going to send them to another teacher because I didn't want it to be my problem, right? You 3, you're not in a group, go across the hall. I wouldn't really do that. I'd find a way to make, okay? But we're going to pretend that's what I did. Bring this 3 down, and suddenly, this new teacher now has 33 kids. I'm so evil. Now what? I want to put them in groups of 4. How many groups? 8 groups, because that's the closest without going over.
Yes.
8 times 4 is,
32.
and I have 1 student who I'm going to just send to the principal's office because,
They're bad.
no, I don't know. No, just I have 1 left over, 1 remainder. Yeah?
Yes, ma'am.
Remainder 1. And if I were to write this as a fraction, so I don't write the r, I would write 48, the remainder, over whatever it was I was dividing by. You remember doing that?
Yes.
All right. I want your really honest reactions to the next thing I'm about to say. The thing we just did with these numbers, I can do to that.
No, we can't.
No.
I
You want
need
the
you
honest
to.
reaction?
Yes.
I'm
No
thinking.
way.
That looks so complicated.
Yeah.
Does it have to be in fractional or you put a decimal?
I'd like it in fraction forms.
Miss, I don't know how to
Well,
put it
you
in
can make
fraction.
a decimal into a fraction.
Yeah.
All right. So your reaction to we can do this, which felt really comfortable, you know,
I like that.
like
better.
this was
Miss, how do you
okay.
put it into
I
a
like that
fraction?
better.
This,
Yeah.
I took the remainder
Uh-huh.
and I put it over the thing I was dividing by.
So it's always gonna be like that.
Always like that. Hi.
So the instead of number 4, it was like a 20, and the remainder was like
A 3.
3.
It'd be 3 over. Yes.
Is it ever gonna be improper though?
Is it ever going to be improper, the remainder? No.
No, because the
Hi, quick question. So her question was, is my remainder ever going to be improper, where the top is bigger than the bottom? No, because if you get that, that means that you could put 1 more here and divide it down and have a number smaller here. You always want this number here, this remainder, to be smaller than the thing you're dividing by. Okay? Otherwise, you could have made some more groups.
so there's no chance of you having a 93 over 20.
Correct. There's no chance of you having something weird like 6 over 4,
Oh, okay.
okay? On your remainders, provided you did the division properly. All right, so your honest reaction to we can do this mess to that was?
No.
Let me show you how.
Complicated.
Yeah, it's really not as complicated as your brain wants it to be. You were feeling like it's complicated because, oh my God, there's letters there, and I'm like, ah! Relax.
Miss, can I just look?
Yes, I was just about, yeah, she got it for us. Thanks. We're going to set it up the same way. We put this number here inside of our division house, and we put this number outside the division house, yes? We're going to do that, but this time it's to groups. You don't need to write the parentheses. So here's my division house. Inside goes the first thing. Outside goes the second thing. The entire thing. The entire thing. Okay?
Can we solve the 2t squared and the 4t
Okay.
and then have them be relations to
No, we can't do that. Yeah, no, we can't do that. Yeah.
Question.
Answer.
The 2p minus 7, you divide it by 2 squared, and then by 7, and then negative 39.
I love how you guys are already trying to guess how we're supposed to do this. I absolutely adore this. No, that's not how we're gonna do it. Let me talk you through the process, but I love that you're already trying to guess, even though it's not exact. I love it. It's perfect. Okay. So remember on the first one, we looked at the first digit and said this digit wasn't big enough? We're kind of doing the same thing, but this time we're looking at terms instead of digits. Is this one term big enough to hold two terms? Ladies, stay with us, please. It's not. There's nothing I can do to these two terms that will ever turn it into this one term. At least not without breaking algebra and adding not like terms. Okay? So nothing I can do. I have to scoot over to have two terms. Now I have something that's potentially big enough. Now we're going to simplify it. Look at just the first terms of each thing. The 2p and the 2p squared. What do I multiply to 2p to give me 2p squared? Itself? If I multiply 2p to 2p, yeah, it gives me 4p squared. So 1p. If I multiply it by 1p, I will keep the 2 the same in the front, and I add the exponents just like we did the multiplication a few days ago. I'm going to write this p up here so I don't lose it. Okay, so this p has an exponent 1, this p has an exponent 1. Multiply this to this first term. I'm going to multiply the coefficients. Coefficient of 1, coefficient of 2. 1 times 2 is 2. My variable is p. Add the exponents. 1 plus 1 is 2. P times 2p is 2p squared. And it matches exactly, even the sign. Okay? Now I'm going to multiply to the second term. Okay? So I multiplied here and here. Oh, now I'm going to multiply it to here. So I multiplied this. That was the first one. And now I'm going to multiply the second one. Let me change the color so we can see it. Okay. P times negative 7 is? Okay. And then the step up here said to subtract, right? I subtracted by changing the sign. Okay. I originally had 4 times 4 is 16. I needed to subtract, so I changed the sign and made it a negative 16. I need to subtract. I'm going to do that by changing the sign of everything in that second row. This first term is going to cancel and disappear. I wanted that. 7 plus 7 is?
14.
And then this term is going to fall down.
Just a negative.
Just the negative 39 is going to fall down. Now I'm going to look at the first terms again. 2p times what is 14p? 7, because 2 times 7 is 14. Positive 7, because I want the signs to stay the same right now. 7 times negative 7. 7 times 7? 49. I have a positive times a negative? Negative. So it's a negative 49. Now that I've done the multiplication, I'm going to...
divide by 14?
Where?
Right there.
Right
Last
here?
one. Yeah.
No. In order, the next step here is to subtract this. To subtract, I'm going to change the sign on both things. And then I'm going to add straight down. 14 minus 14
It cancels out.
cancels.
So then positive
Mm-hmm.
49 plus 39 plus positive 10.
And that's it, I'm done.
That's your answer?
I have nothing else left to bring down. This is my remainder.
So it's 10 over 2p minus
And so my answer is the quotient that I found with the remainder. The remainder was a plus, so plus 10 over the thing I divided by. You just did long division on a polynomial, guys.
Question.
Answer.
Do we have to put the plus before no, after the 7 and before the remainder? Or
Yes. Yes, you do. So her question was, do I have to put this plus sign between the 7 whole number constant thing and this fraction? Yes. Otherwise, it looks like multiplication. Do you want to see this again? Yeah? All right. How about on one that maybe starts off looking a little more complicated? Maybe the one on the bottom right of our page? Okay. All right, this one. It looks complicated because it's out of order. It's out of order. It's out of order. So let's rewrite it in order, putting things in order by degree, by the power on the variable. Biggest power first, running down to the smallest power at the end. 3 is my biggest power, followed by power 2, followed by power 1, followed by power none. I have my division symbol, and then the thing I'm dividing by, I get to do it again. Power 1, power none. Easy? Already feeling a lot easier to deal with, yes? We're going to set it up for long division just like we did the first one. The first thing inside the house, the second thing on the outside of the house.
This is the division sign? Or what is that?
Right here, this?
Yeah.
It's supposed to be just a subtraction. Yeah, I started to put a plus and then stopped myself. Sorry. All right, I'm going to play my game again. This is 2 terms, so I need to start off with 2 terms. Looking at the first terms in both. What do I need to multiply to k to give me k cubed? 1k squared. Yes, there's a 1 because our coefficients are both 1s. K squared because when I multiply k squared times k, I add the exponents. 2 plus 1 is 3. K squared times 3 is positive 3k squared. In order to subtract, you must change the sign on everything. And now we can add straight down. These cancel, which is what I was hoping for. -4 minus 3, -7. And I'm going to bring everything else straight down. Repeat. K, -7k squared. -7, +7. Okay, I want it to match this one exactly. Negative. -7 or -7k? Okay, very good, because I need that exponent. Perfect match. -7 times 3. In order to subtract, I need to change the sign of everything. And then I'm going to go straight down in exactly doing what it asked me to do. And then those are going to come straight down. Going to play my game one more time. What do I multiply to k to get negative 9k? It's a negative. Negative 9, yeah. Negative 9. Negative 9 times k is negative 9k. Negative 9 times 3 is negative 27. To subtract, change the sign of everything. Cancels. I'm left with a remainder of 9. Feels okay? Feeling a little better? Más o menos, kind of, sorta, right? Más o menos, kind of, sort of. Okay, let's write our answer real quick. There we go. Now there's another way to do division. Synthetic division. Synthetic division ends up with the exact same answer, but the process strips away the variables so you don't have to deal with looking at letters. It also handles this subtraction embedded inside of it somewhere. So you don't have to worry about changing the signs. So all you have to do is multiply and add, multiply and add, multiply and add. You're done. So let's show you how to do that synthetic division. Okay? Turn the page. The back side of those notes are blank. This is where we're going to scribble all of our synthetic division on. And then I want you to go to your phones. And I'd like you please to bookmark this website. purplemath.com/modules/ let me make sure I have the right webpage. Synth SYNTH div, like division, .htm. purplemath.com/modules/synthdiv.html. Okay? So if you'll surf to that website now, it's going to look a little something like that. This is a step-by-step how to do synthetic division. Ads included. Okay? I would very much like it if when you're doing your practice homework and you have to do synthetic division, that you keep this website open on your phone, on your tablet, on your computer, wherever you like to surf the internet, so that way you can refer back to how to do the steps. Okay? I want to walk the steps with you on the example that we just finished doing by long division to show you the answers are going to be the same. All right? We are going to confirm the answer on this one using synthetic division. Step number 1 for setting this up. We're going to take the thing we're dividing, which is the first item, the stuff that normally goes inside your little division house, and we're going to write it as if we were going to put it into the calculator for matrix. Okay? Which means I'm going to grab just the coefficients, no letters, and if I'm missing a variable, I put a 0. Okay? So if, let's say, I were missing the k squared term, and it went k cubed minus 30k, in the space where the k to the second power go, you'd put a 0 in this matrix looking thing we're about to write. Okay? Okay. Step 1 for setup. Ladies. Step 2, write an upside down division sign, but give yourself some space under the numbers because we're going to write some stuff in there. Step number 3. Find the 0. We're going to take the thing we're dividing by, we're going to set it equal to 0, and we're going to figure out what value the variable needs to have so that this equation is true. Solve for k, basically. This number goes here. Our setup is done. We're ready to divide. All right, here's how we do that division. There's 3 steps. The first one you do once, the other 2 you're just going to repeat until we're done. Okay? First step, bring that down. Don't do anything to it, just drop them down. Yeah? All right. Step 2, the first one we're going to repeat. We're going to use multiplication. We're going to multiply this number we put there by that result. And the answer goes here. Step 3, the second one you're repeating. Add straight down. Go back to step 2. Take this number, multiply. Now we're going to multiply it to this number, and the answer goes there. Repeat step 3. Add straight down. Go back to step 2. Take this number and multiply it to there. Write your answer up here. Repeat step 3. Add straight down. You're done.
Yes.
Well, we have to translate this answer because we were originally given it with variables, and what I have now has no variables. So we have to just translate it back into something that has variables. But once we're done with that, we're done. We have our answer. All right. When I was setting up this synthetic division to begin with, this column held information about k to the 3rd. Yes? And this column held information about k to the 2nd. K to the 3rd. K to the 2nd. And this column held information about k to the 1st. And this column held information about k to the 0. Our constant, right? K to the 0 representing our constants. No variables? Yes? Our answer is going to come very much in the same thing, but all of those columns, 1 power less. This column now contains information about k to the 2nd, which is 1 power less than the 3rd. This column now has information about k to the 1, because that's 2 minus 1. This column has information about k to the 0. That's my constant. I should not have a variable anymore. And this one, 1 less than 0, -1. Basically, this is telling me that this is my remainder. Okay? My coefficient of k squared is right here. Here's my coefficient on k. My coefficient on k to the 0, which means I don't have to write the variable. And then my remainder, which I write as a fraction. And I put it over the thing I was dividing by before I put it in synthetic division. This is my results on synthetic division.
Oh, I like this.
I prefer the long division. Mostly because I think that I may have fallen asleep that day in Algebra 2 when they first taught me how to do synthetic division, because I never got it. Even now, I don't think I'm feeling as comfortable with it as I could have, even though by now I've explained it like 6 times today. Okay? So I'm feeling a lot more comfortable with it than I did 20 years ago. But I would still, if given the choice, I would still prefer long division. I'd like you to practice both. Here's how. I'm going to pause the recording so I can give you the assignment. Thanks again for watching.